Welcome in the fifth section of our course. In this section, we'll be plugging regression into deep learning network. So at the beginning, we will focus on explanation of logistic regression and regression algorithm. Then we will be constructing regression using constructs that are available in machine learning and deep learning toolkit. Once we'll be able to construct it, we'll be using it together with deep learning 4J layer. And finally, we'll be running our network. And this is the first video in which we'll be doing explanation of regression algorithm. So to understand regression, we need to compare supervised and unsupervised machine learning algorithms. We will answer a question what logistic regression is, and we will be looking at the simple example of logistic regression. Logistic regression is the simplest case of regression algorithm because it takes only two variables, 0 or 1. So basically machine learning algorithms can be grouped into two main categories. First one is supervised learning, when input data needs to be labeled. So if you remember our previous section, when we trained our classification based on the image data that was labeled from 0 to 9, that was supervised learning somewhat. Second group is unsupervised learning, when data is not labeled and we need to extract those features dynamically. We don't know upfront if data is labeled somehow, so we need to extract it. And logistic regression is from supervised learning, regression also as well. In logistic regression, data that we need to analyze needs to be labeled binary, 1 or 0. Input could be vector of numbers. For example, we can take text that is transformed using word to vect, and we could label it binary, as you remember from the second section. Lastly, that vector, feature vector, could be, for example, if something was written by author or not, or different examples can be applied. So let's look at the example input of logistic regression. So, for example, we can focus on the use case of hours of studying versus passing of exam. So, passing of exam is labeled with 1, not passing with 0. And we have one feature vector. Feature vector has only one variable, that is hours of study. So we can see that, for example, if someone studies half an hour, he didn't pass, so we are labeling it with 0. Then we will go to the 0.75, 1.0, still labeled with 0. But when we go to 2 hours, then labeled with 1, so it means it passed. And the following data could be used as an input to logistic regression algorithm. So example result, such logistic regression will give us probabilities of passing exams. So we can ask about a feature that was used to train the model, and that was hours of study. So we can pass that feature as an input to predict method, and it will return the probability of passing exam. So we are giving a feature vector and we are returning the probability. This is how logistic regression will work.